Hello, everybody. Welcome back. Blue Thunder here. It is week 353 for the LeetCode Contest Corner. Well, okay, it's LeetCode Contest Corner. The LeetCode Contest is week 353. I have not done this 300 times, not even close yet. Um, I hope y'all had a good week. And yeah, well, let's just get right into it. I was able to maybe if I reload, I got one of it. I turned it in. What the shenanigans? Well, okay, I don't need to click it actually. Did I forget that I didn't submit it? Oh no. I thought I did though. Yeah, it gave me accepted. Bam. That sucks. Oh, now it's green. I don't know. I don't know if that counted for the contest, but that's all I got done. I wasn't gonna win anyways. Whatever. That was weird. Um, uh, yeah. Anyways, okay, congratulations to Chris T for getting a first place. Good job, good job. Yeah, all right, let's get into it with the first one. Um, as always, I'm gonna read the the description, then I'll try to explain it in easier terms in case you don't get it, and then I'll show you my code. So here we go. Find the maximum achievable number. You are given two integers, num and t. An integer x is called achievable if it can become equal to num after applying the following operation no more than t times. Increase or decrease x by 1 and simultaneously increase or decrease num by 1. Return the maximum possible achievable number. It can be proven that there exists at least one achievable number. Okay, so um, this is pretty simple. Hold on. Okay, sorry. This is pretty simple. It might sound a little weird, but it's not too bad. So you got a number here. You got 4. All right, and then you might be a little confused. Where does x come from? Okay, so x is our number. We're kind of creating x, and we're trying to find the biggest x that can fit with this thing. Okay, so we got 4, and then let's pick x. Let's say x is 5. No, let's say x um is 8, right? Let's see, x is 8. Okay. So we need to figure out how to we need to make them the same number, okay? So how do we do that? We we can increase or decrease x by 1, and increase, and then at the same time increase or decrease num by 1. So we're moving each we're each if you imagine a number line, we're moving each number on the line. We're trying to get them on the same number. Um, Now, so here theoretically we could increase them both or decrease them both, but that would be kind of pointless because then they would be the same distance away. You wouldn't make any progress. They would just be different numbers. So we don't. So then, what does that mean? It means each time we want it to be opposite. If we increase x, we want to decrease num, or if we decrease x, we want to increase num. So you increase it by 1, so it's num is 4, and then we got 8. So what we want to do is increase num, so num becomes 5, and then decrease x, so x becomes 7. Are they the same? No. Okay. And so do it again. Num 5 becomes 6, and x become 7 becomes 6. So then they're the same number, and there we go. But another important thing, we can do that operation no more than t times. So 8 wouldn't work for this because 8 is too big. So we find out that 6 is the correct one because we only have see because we got t as 1 here, but we only need to do the operation once. Um, so, see, we increase yeah, it says here we increase num 4, it becomes 5, and we could decrease x to down from 6 to 5, so they're both 5. So we just need to do the operation once, which fits within t, and so x is the biggest one. Um, yeah. So um, and t, to be clear, could be 0, which is kind of important, a little bit important. Um, and so there's a couple other things that I'll get into that I hopefully I remember when I go through my code. So let's go through it right now. Um, so same thing. We got Boolean achievable. Uh, this kind of changed a little bit. I didn't necessarily need it to be up here, I guess. Um, so, but it keep track if it's achievable. Um, basically, this will mean that the number that I found, the x that I found, we can't get it within t stuff. But just to be clear, just because it is achievable doesn't mean it's the maximum achievable, right? Because because we could, like earlier, we could do 8 if t was bigger. So if t was big enough to include 8, 6 would still work for x. It would still be achievable, but 8 would be the maximum for like a different number for t. So yeah, so that's important to remember. um, so yeah, so I have this Boolean variable for later. It'll say, hey, this 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 current number is achievable. All right. So then down here, so we're gonna want to keep track of num and x. Now I set x to equal num because uh you can all so when we start checking numbers, well, first, if none of them work, it will always have at least one number because if x is num, that is an achievable number. You just don't do the operations, you do it 0 times. So even if t is 0, it'll still work. Like, hey, that's the same number. That's the maximum number because we can't do the operation at all. So, so yeah, we start x at num, and then if t is bigger, we don't need to start below num because we know we can do num. So why would we want to do below num? We don't want that's not we don't want to do that. Now then I'm gonna skip these two for a second. Um we got biggest. This is the achievable number. This keeps track, okay, what's our current biggest one so far? Um and yeah, the same thing I said as num, just to keep track. Yeah, so yeah. So that's what we got so far. Now, what's these other two? These seem like complicated names. No. So, all right. When we get into the stuff later, we need to do stuff with X. We need to, subtract and add to it, and subtract, add to num. So I created a new variable called flexx and flexinum. It's flexible. You're allowed to do stuff with them. Um, the other numbers, you're not allowed to do anything, but these two is fine to do what you like. Um, so yeah, basically, like, I just need to remember to reset these, but otherwise I can use them a little bit. And it's important to just separate them, just keep track. So that's that. Whew. Um, okay, so then, now this looks like a little complicated, but, well, excuse me, it's not too bad. All right, so this is an absolute value. This is just like, so, so this is taking x minus num. So this will just give you the distance from x's from num, basically. And in case num is bigger, I have absolute mathed out absolute value, so this will be a positive. So it's if x is 2 and num is 4, this will be -2, but then the absolute number value will make it 2. Um, yeah, so we got the distance x is away from num. Then we got um, num, so the number plus t times 2. So t is the number of operations. Um, and so this is saying, so this is as far as, this is going to be a number. Okay, all right, hold on. So let's say num is 4 and t is 5, okay? I'll put a t next to 5. Um, so, I mean, think about it this way. So that means we can do 5 operations, right? Well, each operation moves the numbers together. It moves the distance. The distance goes down by 2 because each number gets closer to each other by 1. So the num gets bigger by 1, x gets smaller by 1. So then the distance gets smaller by 2. So 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 how so the opera so we got five five times we can decrease the distance by 2, right? So we that's what this t times 2, that's the distance we have. The distance from each other. That's the most we can do it, right? Um and then I have num plus that. I think I have this right. Anyways, yeah, num. So the distance from num. That's the highest we can get from num. Um, I'm trying to think. Yeah. So wait, this is the distance from num. The distance is less, as long as the distance is less than, I guess thinking about it, right? Because this is the distance, and this is the distance. This is the most distance we can have, and this is our current distance. I'm thinking, yeah, I probably didn't have to have num plus here. Don't quote me on that. I'm not gonna. I might get. Oops. I might get rid of it later, see if it still works. But I might not need this num here. Um, so mm, yeah, it's a little weird. But yeah, but basically this is saying if the distance we currently are at is, if it gets greater than the most amount of distance, then we're gonna end this while loop. Now, this might be like, oh, you got an error. Why doesn't that break your code? It doesn't really. We could honestly do this as many times as we want. It's just at least we need to make sure we go through as many as we can. The actual like we'll keep track of t later on. Okay. Hopefully, I hope I described that all right. Um, but yeah, so basically, we're just gonna keep. This is gonna tell us to keep going until we get a big enough x that our honestly our goal is kind of get to an x that can't be achievable, that's like too far away that t can't reach anymore, right? So that's what this while loop is all about. So then we set achievable to false, which is here. I think I probably could have declared the variable here, but doesn't really matter too much. And then we get into the for loop. Now this is where t is important, and I think I got it right. So this for loop is just telling us, hey, do the operation this amount of times. If we find a number like down here, I'll break. So then we'll just break out. But if otherwise, just keep going until we can use up all our operations. That's what this is saying. So then we get to this first if. Now this is a little interesting. You might notice I got the same if statement right here and down here. Um, so, what's that about? Well, it's a little weird. This if statement will really only happen if if we're on the num if we're doing this the first time where x is equal to num. So that means flex of x will equal flex of num. So it's achievable and it's true. Um, I think yeah, because this is important. Um, yeah, because otherwise, then down here I'm going to change stuff around, and if they're already equal, then it will be messed up. But if they're not equal, if we're starting at a different number, then this will never be true otherwise. So it's a little weird. This is the best way I figured it out because I started with the wrong way of doing this and I fixed it and I came here. So yeah. So then it's pretty simple. Then we do, hey, if flex x is greater than flex num, that means the number x is bigger than num, then we make flex x smaller and flex num bigger, moving them closer. And then otherwise it's the other way around. So we do that. Then we have two different numbers. They could be the same, so we'll check again. And if it is achievable, we'll set achievable to true. Otherwise, we break. So yeah, so then we do this t times. If anytime we get an achievable number, it breaks out of this for loop. But if we go through it and none of the numbers never equal each other, that either means the operation is too far, it's like more than t away, or there's a weird scenario where it's like um, the numbers are right next to each other. Like num could be 5 and x could be 6. So then we go down here. Um, no, we go here. So then x becomes 5, but then num becomes 6. So then we repeat again, and then it keeps switching them, but they never become the same number, right? So then that won't be achievable. Then we go through that for loop, and now okay, we're looking for, all right, do we have an achievable number? If we do, we'd say yes. We make the biggest we x biggest equals x. Just hold on to that. Because we want it to be x. That's important because um we don't we want the original number. We don't want the number they'll end up as. That doesn't matter. We want the original number that x will be, that is achievable, that can be changed into the number that is same as num. So yeah, that's biggest. And then so that keeps, then we'll hold on to that. And then after that, we increase x again, which will, if you remember, it'll increase the distance over here, so that'll keep track of that. Um, and then we'll reset flex x to the new x we have, and flex the num back to num, just so that we can use those guys. And then it restarts. It goes back to the beginning of the while loop. And yeah, we keep doing that. Keep checking if each x is bigger, if it can be an achievable number, and then eventually, the number, like I said, the numbers will get too big; it won't be able to reach it. Um, and then yeah, then we'll come down here, and then we'll return the biggest number, and that will give us the result. Um, as you can see earlier, I did some testing, and this is, and I was having issues, so I like printing everything out, trying to figure everything out. But this is my successful attempt. It was working. Got 6, which is correct. So yeah, now it works, and I think now it'll just print 6. Yay! All right. So now I'm curious. If we get rid of this num, will it still give us 6? Moment of truth. It does. How about that? Okay, so right, it's one of these things where it's hard to keep track of what I'm keeping track of. So yeah, so this is just saying, hey, okay, t is the distance, right? So we're seeing the distance, and x minus num. Uh, yeah. So if I didn't, I could have just had x here, and then if I had num plus this, then that would have worked. But since we're getting rid of num here, we don't need to add it here. But again, it doesn't matter. With this one, it can be done a few extra times. That's fine. I guess mine is technically a little slower, but otherwise, it is not a big deal. So that's how I did this one. This is the only one I got done today. I looked at the other ones. I couldn't keep my head straight. So, um, yeah. So I hope you guys enjoyed. Um, Hope you got a lot out of this. I hope you enjoyed this video, I guess. I don't know. Maybe you learned something. Maybe you uh, figure out how to do it better than me, and you can feel smarter, and it's good for you. I'm glad you're smarter. Um, and I hope you have a good week. I hope you had a good week. I hope you have a good week, and I'll see you next week. Um, Bye. Hmm. Man, really wish I could figure out how to do this one. This one's really tricky. You know what? Independence Day was the other day. I know just the person to ask. How are you, Uncle Sam? I'm doing great, thanks for asking. I'm just enjoying the freedom and democracy that this land of opportunity provides. How are you? Are you feeling patriotic today? Well, Uncle Sam, I'm doing okay, but I need help with a coding challenge. Since it was the 4th of July recently, I figured I'd ask you. Would you? Sure, I'd love to help with your coding challenge. Coding is one of the many skills that Americans excel at. We have some of the best programmers and innovators in the world. Just look at Silicon Valley, Microsoft, Google, Apple, and many more. They are all American companies that have changed the world with their technology. What kind of coding challenge do you have? Is it related to America in any way? I need you to write a Java method that does the following. You are given a zero index integer array nums and a positive integer k. You can apply the following operation on the array any number of times. Choose any subarray of size k from the array and decrease all its elements by 1. Return true if you can make all the array elements equal to 0 or false otherwise. A subarray is a contiguous, non-empty part of an array. Some constraints are: 1 is less than or equal to k, which is less than or equal to nums.length, which is less than or equal to 105, and 0 is less than or equal to nums I, which is less than or equal to 106. That sounds like an interesting challenge. I'm glad you chose Java because it's one of the most popular and versatile programming languages in the world. It was also invented by an American, James Gosling, at Sun Microsystems, another American company, US. Here's one possible solution for your challenge. Astonishing work as always, Uncle Sam. Thank you. I appreciate your kind words. I'm always happy to help a fellow American or anyone who loves America.